So, hello, folks. We are joined today by Dr. Sean Brown. I'm Dr. Cole, and I have a little feeler around for people who might be interested in looking at or understanding a bit more about the complications associated with diabetes, particularly pertaining to male infertility. So, it's interesting how female infertility and complications around diabetes are pretty well appreciated and understood. But for some reason, a lot of male health is not fully given the same impetus or the same degree of discussion. And I hope that today, with our expert all the way from Scotland, we'll shed some fresh light into it. So, shall we start by just saying hello, Dr. Brown?
Hello, hi everyone, and happy St Andrew's Day and a belated happy Thanksgiving.
So the structure of our conversation today was just going to be quite straightforward. I'll begin by just quickly describing a little bit about the background around diabetes. We're doing all this, of course, with the context of November being World Diabetes Month, Awareness Month, I should say. And although November is closing to the end, the crisis around diabetes is annual and perennial, and we'd like to change that. So I'm just going to share some slides with the group today and go over the essence of what diabetes is, and that hopefully will lead into the expertise that Dr. Brown has to offer. And I think maybe Dr. Brown will also begin by discussing a little bit about his actual research and background, and then the general concept of where things are going wrong with individuals, patients, and care providers who are suffering with these conditions. So let me just share my screen. This is a bit of a challenge, excuse me. Dr. Brown, if you could confirm for me that you can see the screen?
I can see that, yes.
Perfect. That is the assumption then that everyone can. So we generally like to believe that diabetes is a pretty straightforward disease. Nearly everyone likes to think of it as the pretty popular type 2 diabetes. And of course, there's nothing wrong with that. Type 2 diabetes is possibly the largest population of diabetes, or individuals with this pathology are the majority. But diabetes is not only a complex condition, but also a condition that comes in different facets. The autoimmune type is type 1 diabetes, which is represented by a smaller group of individuals, but at the same time, it has the highest impact in terms of cost and the quality of life being changed. These individuals, more often than not, will have diabetes at a much younger age and will live with it all their lives, being completely dependent on insulin. Then there are genetic forms of diabetes like MODY, or the maturity onset diabetes of the young, gestational diabetes, which often resolves after a woman has given birth to her child, and then there's diabetes that is secondary to drugs, to other conditions like pancreatitis or Cushing syndrome and other endocrine conditions. But none of that really still defines diabetes. I think I'm missing my important slide here now. Apologies, this is slightly confusing, but coming back to this, what diabetes really is that it's a condition of a number of errors in the body that lead to chronically high fasting blood glucose. So traditionally in the body, once we've consumed food, within 15 to 20 minutes, the body releases insulin. This is what you can see. I can't do a pointer, but cells in the pancreas called the beta cells will respond to high insulin or glucose in the bloodstream, and they will secrete insulin into the blood. And what insulin does is it essentially asks all your major metabolic tissues like the muscles and the kidneys and the liver to start taking up glucose from the bloodstream and clearing the bloodstream of extra glucose. Think of it in a way as a feeding line. The insulin basically is just monitoring the feeding line and allowing for the different organ systems to pick up glucose so that their energy resources are replenished. Now, the problem happens when there's not enough insulin, or the cells or these organs like the liver, the muscles, and the kidney fail to respond to insulin. And that is what leads to type 2 diabetes. The other side of the story, and this is the part that a lot of people don't appreciate, is glycogen. So when we have excess insulin in the body and the blood glucose begins to dip, this is where the alpha cells from the pancreas release glycogen, which will then start breaking down stored glucose forms or stored energy form in the body, or stored nutrients in the body in the form of glycogen back into glucose into the bloodstream. So what I'm really trying to say is that glucose and its availability in the body for something that is basically powering our life altogether is very well equilibrated between two hormones. There's insulin on one hand, and then there's glycogen or glucagon rather on the other hand. So a lot of the very final steps of glucose control in the body come down to these two hormones. But long before these two hormones come into play, you have to think in the terms of the macros or the larger context of energy consumption. And this is why control of whole body energy is actually even a step away from insulin and glucagon. So how do we understand the concept of hunger? Firstly, we have a hormone that is secreted by the stomach called ghrelin, which triggers the body to understand that we're hungry, it's time to consume. Once the body consumes food, once we've eaten, like I said, within 15 to 20 minutes, insulin is released in response to glucose levels in the blood by the pancreas. And then again, when there's excess energy, so like I said here, if there's excess glucose in the body now, essentially the body starts putting away the extra glucose into the organ systems and later as glycogen. And if there's too much glucose, which is traditional now for most modern dietary habits, that excess glucose goes into fats. Now, this is where the adipose tissue or your fat storage system comes into place. The adipose tissue has the other important hormone, leptin, which signals the body to say, you've eaten enough, you're satiated, stop. So at the very micro level of glucose control, insulin and glucagon become very important. But when you think of the whole body energy, you're basically looking at several hormones that come together to help us realize when we need to consume food for energy, how we need to regulate that energy specifically in that acute moment, and then how do we stop long term from over consuming for energy. And of course, this is something I've highlighted multiple times during other conversations, other podcasts. The lack of control of glucose in the body eventually is what leads to diabetes. And the biggest problem around diabetes isn't the lack of glucose control alone, but the fact that it is associated with a number of comorbidities, a number of complications. And these go straight from depression to eye disease to kidney disease to very slow wound healing, heart disease in some people. And as I mentioned, infertility is part of it. So in women, infertility associated particularly with PCOS or polycystic ovarian syndrome is common with women who are either pre-diabetic or suffer from type 2 diabetes, but it's not a very well explored topic in terms of the male population. And what we'll have now is just a brief indication of just the number of research papers that have tried to consider and investigate diabetes-associated male infertility. And as you can see, the research only really started in the 1960s. And up until fairly recently, there have only been about 50, 60 odd papers annually talking about male infertility in the context of diabetes. So this is where it becomes really important for us to have a discussion with somebody with the expert background that Dr. Sean Brown has to hopefully gather a little bit more based off of just the little summary you've had. Sorry about the rush summary about the different hormones that play into diabetes, to hopefully help you understand where and how male infertility feed in and potentially ways in which we can help people diagnose it better and maybe even control it better. So over to you, Dr. Brown.
Thanks, Scotty. So just to say, I'm not a physician. I'm a basic scientist. I'm a senior lecturer, associate professor in biomedical science, with a specialism in male infertility. And what we're interested in is trying to figure out the cause of diagnosable, if you like, male infertility. So, for example, cases where IVF fails, there are no reliable ways of diagnosing any issues with the man's sperm before IVF. So this is very much what we're interested in. It's interesting, some things that you said there that were interesting. The paper's published. It's kind of taken off, but it was actually recognised back in the 11th century, believe it or not, that men or people with, or actually men with diabetic symptoms had problem with their, shall we say, sexual performance. And so this kind of alluded to the pathology that goes along with diabetes. And of course, you've mentioned neuropathy, and that's one of the issues. Also, you recognise the important issue that the male is overlooked. And I don't know if the male is overlooked or the male is rather reluctant to sort of go forward. And as I said, there's the ability to diagnose a man with fertility issues is very difficult unless he presents with either no sperm or sperm that don't swim very well, or sperm which are obviously morphologically abnormal. That is, they don't look like normal sperm. So I don't know, have you got my slides there, Curtie, you can put up? Because I thought it'd be worthwhile going through just the process of how sperm is made at a sort of very overarching physiological level.
Absolutely. We're up.
Yeah, very nice. So that's a kind of classic picture, and maybe it sort of captures why the man is often overlooked. Because if you look at the very bottom, the woman produces 1 egg a month, and so that's a highly precious cell, whereas the man can produce, even in a bad case, millions of sperm, up to sort of hundreds of millions of sperm in a single ejaculate. So the man can produce this arguably at reasonable volume and cell number every 24 to 48 hours. So perhaps it's not surprising that the man has been historically overlooked. But we appreciate now that up to 50% of the cases of infertility are due to the male. So to overlook that is overlooking 50% of the causes. And so we consider that a gross error. And so that's why we spend so much time and effort into this research area. Would you mind clicking to my next slide, please?
Certainly.
So this is not a man thinking about sex. This is actually how spermatogenesis, or the production of gametes, and that includes the females, is regulated. So the ultimate master regulator is the hypothalamus, and you can see there it's kind of in the middle of the brain. It's about kind of at the bottom of the brain. That, along with the pituitary gland, which is right next to it, regulates the hormonal output, which drives the production of gametes, the sperm and the egg. And the reason I mention the egg is, if you go on to the next slide, is that the pathway, the biological pathway, is essentially exactly the same in the male and the female, to the extent males and females possess the same hormones. Now, that might come as a surprise, because the man is supposed to produce testosterone, which is correct, and the woman produces estrogen and progesterone, which is correct. But the man also possesses and produces estrogen and progesterone, and the woman also possesses and produces testosterone. It's just the levels of these are very much different between the male and the female. And so this is one of the issues. So if the balance is incorrect, such that they are imbalanced, then this can upset gametogenesis. So the hypothalamus produces a hormone called the gonadotropin releasing hormone, and that acts on the anterior pituitary. So the anterior produces two hormones collectively called gonadotropins, called follicle stimulating hormone and luteinizing hormone. and they collectively act on the gonads, so that's the testes in the male and the ovaries in the female, to stimulate the gamete production, and that is the sperm or the egg. Would you mind clicking to my next one, please? Oh, that's come out a bit strange, but the point is that testosterone is produced at high levels in the male, and that actually acts on a negative feedback loop to modulate the release of gonadotropin-releasing hormone and follicle-stimulating hormone and the luteinizing hormone. So what you end up with is this kind of cycle of highs and lows. Now, these are not extreme highs and lows. They are natural physiological ebbs and flows of these hormones. And it's the same thing with estrogen and progesterone in the female. So they'll act back on the hypothalamus and the pituitary to modulate the gonadotropin release and therefore modulate the estrogen and progesterone output. Now, the situation in the female is clearly more complex because these hormones actually are first are stimulatory, then they become inhibitory as the egg is released. But we're not going to spend too much time on that. We're going to just concentrate on the male, really. I think, was that my last slide on that?
Yes. Right.
Yeah.
So back to you.
Yeah, back to me. So the way I thought about this was, you asked me to talk about diabetes, but fundamentally, when you think about diabetes, actually, it's a spectrum. You've mentioned type 1, type 2, but you also mentioned obesity. So you don't just wake up in the morning and you're diabetic. It's kind of a long process. And it's actually the same thing with infertility. So there's a spectrum of infertility, and that's very important to understand as well. So clearly at the extreme end, and I think the female is the best example of this, there's a finite lifespan which the woman can produce, if you like, good eggs. So, sort of towards the late 30s, certainly into the 40s, the quality of eggs drops off, and then, of course, the woman enters menopause. So you can see that the woman, as an example, is a natural spectrum of fertility. So there will be a peak, and then it will drop off. And so biological variability is something that people don't like to consider because it's extremely difficult and it's extremely complex, but we have to deal with it. And so it's important to recognize that, and it's important to recognize that infertility is a spectrum. So whether or not that's a problem with the production of sperm, or it's right through to the a live birth, any problem within that whole spectrum falls into problems with fertility. So you can be infertile because of a huge number of issues, and also there's a compatibility issue. So one man is probably going to be slightly more fertile than another man just because of difference in sperm numbers, perhaps. But there might also be a couple compatibility, and that's something which obviously you cannot deal with because you can't say, okay, maybe you should go and get a new partner. But again, in the extreme case, that actually happens because you can have sperm donors. So at least at a cellular level, you can take care of that. So it's important to consider that. And the reason it's important is because when it comes down to individuals suffering from infertility, there may be something we can do about it. Particularly when it comes down to obesity and certainly type 2 and maybe even type 1 diabetes. Because, for the obesity and type 2 diabetes, I think it's very much recognized it's a lifestyle issue that's impacted on their health. So I was just looking around the literature, and as you say, the publications on the impact of diabetes on fertility has taken off. But quite interestingly, it's very difficult to tie down a very specific cellular dysfunction. And I think one of the reasons for that is because you're studying humans, but also because of that spectrum. So to do a very controlled study is very difficult, because how do you have individuals, how do you have a significant number of individuals with exactly the same type of diabetes and manifesting the same symptoms? So that's very difficult. So what I tried to do is I've looked through literature and see what the most common issues are and see what the commonalities are, not just within human studies, but also how that correlates with animal work as well. And so there's some interesting things that have come out of that. And one of the things, so what I started with was just obesity. So you can be a little bit heavy, but you might not necessarily be diabetic, and you might not be manifesting pre-diabetes. And so one of the things that came out of that, and one of the more interesting one, was a hypothesis of scrotal hyperthermia, believe it or not. So what I didn't mention was that spermatogenesis, the reason the testes are outside the body is that spermatogenesis has to occur at a temperature which is lower than body temperature. And so any restriction on sort of testicular freedom, if you will, can actually impact on spermatogenesis, to the extent that there's been a study out this year looking at men who are attending a fertility clinic, so presenting as having problems with fertility. Those who regularly wore loose-fitting boxer shorts have better sperm parameters and actually hormonal parameters as well. And the reason the hormonal parameters can change is because the hormones, the follicle-stimulating hormone, the luteinizing hormone, can be released at greater levels to try and compensate for any spermatogenesis issues. So I think a very basic tip is, gentlemen, just wear loose boxer shorts. So that's one thing. Another thing with obesity is that it can present problems with sleep. And I think the headline for all of this is look after your testosterone. Whatever you're doing, you've got to do that, because that drives spermatogenesis, and you must do it naturally. The irony is, if you supplement with exogenous testosterone normally, like a bodybuilder might, you'll actually shut off spermatogenesis. So it has to be done, a strategy has to be undertaken to maximize testosterone production naturally. And one of the issues with people who don't sleep well, for example, if very obese, is that that can affect their hormonal profile. So that will impact spermatogenesis. And the other issue is with increased body fat. This increases the amount of enzyme which converts testosterone to estrogen. So this is why I said men possess estrogen, and it appears to be higher in individuals who are obese. So if a man has elevated estrogen, then that's going to reduce the sperm count. So again, that's going to impact on ability to conceive. And so this is why it's a spectrum, because a man will naturally have a sperm count, if you like, and then, but that could be, could be borderline what's called WHO criteria as being subfertile. And if he's on that borderline and there's issues with further issues with spermatogenesis, that's going to take him under. So fundamentally, it's a numbers game for the man. Does he produce enough, and do they swim well? So one of the other issues with obesity, and I guess with diabetes as well, is it's an inflammatory condition. And if there's any kind of inflammation in the testes, then that's not a good thing for sperm production. And it's not a good thing for sperm themselves, because sperm are damaged by some of the molecules which are released by these immune cells. So obesity, although not necessarily manifesting diabetes, is kind of I would argue, towards the very early stage of developing pre-diabetes. So on the issue of pre-diabetes, again, looking at what's been published out there, if men who are presenting with pre-diabetic symptoms are more likely to present with infertility. So already at that early stage of diabetes, it can be impacting fertility. And again, one of the issues is that the hormonal profile is upset. So the testosterone is lower and the estrogen is higher. So that sort of fits into the fact that the chances are the individual will be carrying more body fat, and that will manifest with greater aromatization. It's called conversion of testosterone to estrogen. There's evidence that the central nervous system will try and adapt to that and produce a higher follicle stimulating hormone. So that may be an indicator as well that there's pre-diabetes is having issues with the spermatogenesis. Also related to the inflammatory response, there's the impact on spermatogenesis. There's a higher rate of men with producing no sperm at all with pre-diabetic symptoms, but also perhaps more worryingly is that there's a higher rate of DNA fragmentation in the sperm itself. So that's suggesting that either the germ cells are damaged and that's carried through to the sperm, or as the sperm is produced, the DNA is damaged along the way. And the problem with DNA fragmentation is then the sperm cannot fertilize no matter what's done. So it doesn't matter if you do IVF or intracytoplasmic sperm injection, you won't get fertilization, the embryo won't develop. So that's a big issue. For full-blown type 2 diabetes, well, there's some controversy in the literature, but I think that comes down to, again, the cohort, which can be studied, because, as I said, it's very difficult to get individuals with the exact same symptoms. What it appears is that men with type 2 diabetes universally have decreased sperm motility. So that would impact not just natural fertilization, but also in vitro fertilization. And so one of the things that we argue in our research is that we're very keen to be able to develop treatments to move sperm towards more natural fertilization, because that's allowing the process of natural selection to kick in again. Also, one of the issues is you have increased immature cells. So it's again showing spermatogenesis isn't complete, and also increased cell death. So the cells are actually, it's called apoptosis, so they're basically dead. Also, matching with the issues with the pre-diabetics is there's higher DNA damage, but also it's been noted that there's higher mitochondrial damage as well. So not just their ability to produce energy, but also actually the DNA content of the mitochondria as well is impaired. So that's problematic as well. So one of the issues as well is also having decreased motility, is also lower concentration of the sperm, so that impacts on the numbers game. So lower numbers and they don't swim, then that's problematic. There's been some work done looking at the impact of diabetes on the sperm themselves. So treatment with advanced glycosylation end products, which is basically a metabolite of glucose, if you like, impairs the sperm membrane, for example, and impairs motility. And also there's increased reactive oxygen species that is produced. And so reactive oxygen species production, I think, is part of the inflammatory response. And so that can damage the sperm membrane. And there's been some very nice work that's been done in Australia to show that actually, if you have an impairment at the level of the sperm binding, then with reactive oxygen species, then you don't get fertilization or impacts fertilization at IVF. So that's one of the big issues. So the man could be producing sperm that are not just have poor motility and low numbers, they could actually have membrane damage, and they could be carrying DNA, which is suboptimal anyway. And of course, the issues with the hormonal imbalance carries through to type 2 diabetics as well. So that's one of the major issues. Rather perversely, I think that the best model for high glucose levels, the impact of high glucose levels in individuals, is from type 1 diabetics who poorly control their symptoms. And again, it's the same kind of pattern. The hormone axis is upset, so end up with lower testosterone, and you have decreased sperm motility. So it appears to be, although there's no definitive clinical trials, if you like, the meta-analyses are producing some contradictory evidence. I think if you dig into it, there's certainly some trends there that people really want to have a good look at. One of the things that I mentioned at the start is the issue of neuropathy. So poorly controlled glucose, in extreme cases, can lead to amputation, circulatory issues, and that impacts on the man's ability to get and maintain an erection. It also impacts on libido, for example, and it can also result in retrograde ejaculation. So the man actually might produce sperm, but it just ends up going into the bladder. So in which case the man, can't fertilize naturally. But this can be retrieved in the IVF clinic context. So for I think that's kind of the main points that I wanted to cover. So if a couple are having issues with fertility, I think the number one thing they've got to do is look after the hormones, implement strategies to do that. There are things that you can do by yourself without having to go down the pharmacology route immediately. Also, it's important to get the correct physician. It's important to get a physician who understands the science and is willing to look at you as an individual and as a couple, a unique couple, because you have to tailor your treatments according to you, which is very, very important, I think, because obviously it's down to you want to be treated as that individual, not as a statistic, if you like.
Fantastic. Thank you. It's a really, really good overview. It just made me think of the fact that I feel so bad now that I started out with such a jumpy summary, because a lot of the factors that you wanted to then expand on, I think I could maybe in another podcast address in greater detail. But the reason we wanted to talk about male infertility, and the reason it is a pressing issue, is because more and more people are developing diabetes at a much younger age. And we ourselves as being the first of the generations that experiences and treats and has to care for individuals who are possibly type 2 diabetic, typically associated with an aging population, even as early as the 20s. So, it wasn't surprising for me in the times that I was interacting with groups that wanted to have education sessions around diabetes, to hear about people dying of strokes from diabetes at the age of 35, 38. And I think one of the factors we didn't address as much, but I think there was an undercurrent around it, is also stress. Psychological stress plays a big role into the quality of life, sleep, and hormonal imbalances. So that plays into a lot of things, both for men and women, for all sorts of functions. But
Yeah, I think you're right. I think it's very important. You know, life's just a bit crazy now. There's all kinds of demands on people, and it's not how we evolved. Um, so particularly when it comes to infertility, you know, it's an extremely stressful issue. It's a chronic issue. It's very difficult to diagnose in many cases. The burden of treatment is you know, still on the woman, and you know that's one of the reasons why we think it's unacceptable that the man has been neglected for so long. It's time we stood up and you know held the hands up and said, you know, some of us are infertile. We need to do something about it. It's nothing to be ashamed of. Um, so it's important that a holistic strategy is developed, and the couple's cognizant of that, and they really think that we have to look at all aspects of our lives, you know, because it's you know, sleep, stress,
Absolutely.
all.
And the other thing that you've also brought to our attention is besides the actual reproductive pathway on its own, a lot of the physiological changes that happen in the obese. So this was surprising for me as well. I hadn't really looked into it, and I'm glad we had you explaining all of this. But even prior to prediabetes, just obese individuals already experience changes physiologically, which promote estrogen, reduce the testosterone. Surely, even if it doesn't impact the reproductive cycle, developmentally speaking, over time, it could lead to other complications potentially. Am I maybe jumping to conclusions
Yeah,
here?
no, you're right. So one of the I hesitant to say accepted hypothesis, something that's argued quite strongly, is the fact that if a man is presenting as infertile, if he has a poor spermatogenesis, it can be indicative. It can be a signal of additional health issues. Um, and, you know, and diabetes is a perfect example of that.
Of course, of course. And again, it's really interesting to go back and forth on just how closely these things are tied together. The body fat percentage versus the body muscle mass, especially. And muscle mass, although it's a plus, a bonus for women to have, is particularly important in men because on the one hand, it is driven by testosterone. On the other hand, it dictates whole body metabolism because men cholesterol, or rather the way a male physiology handles cholesterol and ultimately metabolizes it is slightly different from that of a female. And again, that's both tied to the metabolic health, to the reproductive health, but also to cardiovascular health. So I think it was fascinating for me personally to hear about how these things change and in a way amplify once an individual hits a certain condition of metabolism, be it obesity or type 1 diabetes, which we've actually also shown in our own research can lead to secondary form of insulin resistance. So a lot of people assume that type 1 is only autoimmune, but there is some degree of insulin resistance in individuals with type 1 diabetes too. And a lot of these complications of cholesterol mishandling, a lot of the oxidative stress, as you mentioned as well, come together in multiple ways to affect the entire health of this individual, not just reproductive. But of course, like you also mentioned, reproductive health is an extremely important paradigm that's very often ignored. And it has both a psychological effect on the couple, on the individual, and obviously then physiologically in so many different ways.
Yeah, I mean, what I didn't mention, what I meant to mention was the fact that you know, insulin and leptin support the production of the gonadotropins. So actually, it appears to be now that leptin drives the production of the gonadotropins. And if you think about that, that kind of evolutionary makes sense because reproduction is an indulgence to an extent because you know we don't have to reproduce on a daily basis, but we have to you know stay alive on a daily basis. So what it appears to be is that physiologically, leptin drives production of gonadotropin release, so spermatogenesis, oogenesis, and it's basically a signal to the body to say that it has enough energy to invest time and effort into producing these essentially non-essential, immediate, at least, cells and prepare the body for ultimately pregnancy in the case of the woman. So what happens in type 2 diabetes and I'll mention type 1 in a second, but type 2 diabetes, that is when you have elevated body fat, the leptin becomes too high and it actually shuts off the gonadotropin production. So it has that imbalance, upsets the gonadotropin release. And the flip side of it is, in type 1 diabetes, if the person is extremely skinny, or if, for example, in elite athletes with very low body count, that can upset their gametogenesis because they're not producing enough leptin. So certainly it's recognized in, women who undergo extraneous exercise, are anorexic, they stop menstruating. And so actually one of the reasons for that is that the leptin production drops off. So I think your point that everything is connected is correct. We are one great big physiology. It's all connected.
Absolutely. And actually, this brings me to another really interesting study that I came across many years ago, which I think is also relevant from a comment you made about the DNA quality. So whatever number of sperm is made is also potentially carrying damaged DNA. For individuals during the Dutch famine crisis, the generations that came after individuals who faced a famine in Holland, the next generations were showing epigenetic changes that led them to developing diabetes. So, what you have to remember with a lot of people who are now living with diabetes is that, and even individual candidates who are pre diabetic potentially, is that not only do they live and suffer a lot of the complexities and the complications that come their way, but they are very likely to pass on some of these in a epigenetic way.
Yeah, I mean, that's something I forgot to mention as well, that I think the evidence is out there that people who are diabetics, their epigenetics change, and it changes down to their gametes. And so that will arguably predispose their offspring to becoming diabetic as well. And of course, that will be brought forward, so they'll be diabetic earlier.
Exactly. So it's something of a organic soup that is unfortunately, predisposing more and more people towards diabetes, partially explaining why there's such an exponential increase in diabetes. Projections for diabetes in 2020 were supposed to be pretty different from where they're headed now. So, and I like to throw this fact at a lot of people. It surprises a lot of people, but diabetes claims more lives per second than HIV/AIDS. And diabetes is not even contagious as far as we can tell. So that's really saying something. I think it's something to really appreciate, that not only does it cause a lot of mortality, a lot of morbidity because of all the complications associated with it, it just affects the quality of life of individuals. And it is a very systemic condition. It's a complex, very heterogeneous condition, but it's very complex and affects a lot of different systems and organ systems. So I think just to quickly summarize, Sean, I think this is pretty experimental on our end. I usually end up doing this in a very non-scientific way, but this feels more natural. This is definitely more interesting for me as well. But just to summarize some of the things that we want to take away from this, individuals who are obese, who have, actually, I should also mention, certain Asian populations don't have to be outright obese. There is such a thing as the thin fat population in some subcontinents, like the Indian subcontinent, where individuals are just metabolically unhealthy while they're skinny. So basically, anybody who's metabolically unhealthy, potentially obese, pre-diabetic, chances are that the number of their sperm in men is lower.
Yeah, I think you could argue that is lower. There's an impact on the sort of storage of the sperm as well, and the DNA content can be worse. And certainly it appears to be the motility is affected, which is fundamental for natural conception.
There you go. So pretty much everything that feeds into eventually leading into successful zygote formation or reproductive health is affected. Additionally, there's also potentially the erectile dysfunction in individuals with diabetes, which could be neuropathy driven.
Yeah.
So all of it comes down to hormonal imbalance. And now I guess this is where I come back to you for what are some of the early markers, if any? Have there been any identifications of these markers? I mean, it sounds like it's too late by the time we get and find that things are failing for a man.
Well,
Is there some way it might be?
I think the standard assessment is a semen assessment. Now, This is a bit of an issue because it's supposed to be diagnostic, but there are plenty of cases where it's can be okay and they're still going to be infertile. The numbers can be low, but they can still conceive. So it's very, very difficult. But I think fundamentally that's what's recommended. So a thorough semen analysis at a clinic is necessary. A full blood work would be useful because that would flag up issues. It would certainly flag up their glucose. It would
Mhm.
certainly look at their testosterone. It would look at their estrogen, and it would look at their gonadotropins as well. That would certainly cover. Well, at least it should. If it isn't, then perhaps they should find somewhere that does it. Given the amount of time and effort and stress and emotion that this costs, it's worthwhile, taking some time to find the best clinician in a clinic that will help you.
Certainly, certainly. And again, these will all, so this is the important thing to remember, it can lead to eventual physiological complications in men as well if they're not in the best of health. So, I mean, whether or not, do you think it's necessary that only if a man is considering having a child, is that's the only condition in which he should look into these factors? Or do you think just for general health to avoid any other complications in the future?
I don't think it's one of these things that there's no harm in it, but it's not done routinely. You wouldn't go to your GP for it. You'd have to be referred. It's certainly in the UK. Maybe privately you could ask for it. So if but there are signs. A guy will know if his libido's down. He's not sleeping well. He's not got good muscle mass. He doesn't have much energy. These are all signs that something's up. So you really have to say, is that because I have a fundamental health issue, or is it my lifestyle? That's when I said you got to have a holistic approach at it. You've got to then adopt strategies to improve your testosterone and health naturally. And that's exercise. It's all the boring stuff that people don't want to hear, but it's true. It's your exercise, it's your rest, it's your diet.
Absolutely, absolutely. And again, I think you've pretty much covered all the grounds when it comes to approaching this concept, knowing that the whole body works together. This is an extremely important function of the body as well. And you have to treat it as one potential symptom towards the whole body's health if it's out of line. So again, as we always reiterate, find a way to exercise. I understand that I think resistance training, especially anything that can promote muscle mass, is possibly or directly affect body fat percentage, is possibly a little bit more effective than purely cardio. But at the same time, I would never advocate just one over the other.
No, I think as a strategy, fundamentally, you find it's that equation. You want to have more calories out than calories in. So you sort your calorific quality out, you sort your nutrition out, and you choose something to expend that energy that you like doing. I think that's where you start. And then if you want to, if you're feeling good about it, then you can get into the more resistance training side of things, which I think is a very good thing to do, certainly from a male perspective. But again, there are strategies that you want to adopt within that. It's not a case of you become a power lifter type thing.
No extremes. If anything that comes out of this conversation, I think it's the fact that physiology is happy always in the middle ground, never on the extreme of one or the other, never all insulin, all glucagon, or all leptin, all insulin. So definitely the middle path towards a more or less healthy, balanced life.
Yin and
But
yang.
yin and yang, precisely. So thank you so much for that. I think if you have any other comments you'd like to make, I mean, I think a lot of people would be possibly interested in more questions or have a little more they'd like to know that we haven't had a chance to discuss today. So I'll have your contacts or your, I think your DM details
Yep.
in our description. And I think it's a thoroughly interesting topic. Thank you so much for sharing so much insight.
Pleasure. Speak to you.